Hello everyone, I'm Dr. Cho from the Technical Department of JinkoSolar. Now we are in front of the Cell 1 workshop. This workshop had 13 production lines and with an annual capacity of 5.8 gigawatts. It produces 182 millimeter per cell right now and have room for the N-type cell upgradation. Let's follow me and go inside to see some code processes.
The first thing we need to do before entering the workshop is to putting on the cleaning clothes and shoes, also face mask. Then we will go through the air washing room. Clean air will blow away the dust and particle from outside environment in order to maintain the cleanliness level of the workshop. Firstly, solar wafers will be shipped to this room, where they will be loaded to the AGV through moving belts. Then the AGV will automatically take the wafers to the first process. Later, you will see that for most every step, AGV are used, making this workshop one of the most advanced, fully automatic, high-efficient one in the PV industry. Here, let me show you the first step of cell processing, the texturing process. The main purpose of texturing is to form a pyramid surface on mono wafer to reduce the light reflection and in the same time to remove the soil damage layer from wafer slicing. Now you can see the process of phosphorus diffusion. During this process, we form an N-type emitter by doping phosphorus into the wafer, using high-temperature furnace and charcoal as precursor. You could imagine the wafer is positive part and the emitter is the negative part. Then we have an internal electrical field to separate the electrons and the holes. Next, I will introduce the laser selective emitter process. We use laser as an energy source and the PSG layer as phosphorus source to form locally heavy dope area to ensure good contact with metallization. This process is called chain oxidation. A dense oxide layer is formed on the surface after AC process by chain oxidation, which can protect the heavy dope area and prevent the corrosion during alkali polishing afterward. This process is called alkali polish. First, we use HF chemical to remove PSG layer on the real side. Then we use KOH chemical to polish the real side surface of silicon wafer, prepared for preservation layer deposition afterward. This process is called thermal oxidation. We use high temperature furnace with oxygen atmosphere to form thin oxide on the wafer, which improve the preservation quality and reduce the surface concentration of phosphorus at the same time. Now we are at real side preservation process. We use plasma enhanced chemical vapor deposition method with silane, ammonia, TMA as precursors to dep the aluminum oxide silicon nitride stacked thin films on the real side, which result in an excellent surface preservation quality. This process step is the key for PERC cell and currently this structure is commonly being used in the industry. Next process is called PCVD. This process is similar to real side preservation process step. It also uses plasma enhanced chemical vapor deposition method and only dep the nitride thin film on the front side to reduce the light reflection and improve the preservation quality at the same time. Now we are at laser opening. we use laser as energy source to open the real side passivation layer for metallization contact afterwards. You can see screen printing process here. The both side metallization is complete by the screen printing technology with silver alumina paste to form front side and rear side pattern. The paste laydown and pattern design are crucial for the performance and quality control, also cost balance. We have our know-how inside. This process is called fast firing. The contact between the metallization paste and silicon wafer is formed during this process with peak temperature above 700 degrees C. Follow me to see the process of electrical generation. With the electrical current injection, the hydrogen atom tends to passivate the defect on the interface and silicon buck. Finally, every cell will go through the appearance inspection and the EL/IV testing, then sorted into different categories for further module assembly. The cell quality controlled strictly through these inspections and the testing tools automatically. Above, you have been shown briefly the whole process of cell manufacturing. The whole workshop is a large clean room. The highest clean room level area reaches 1K, which is Tier 1 in the industry. This workshop is currently the most advanced, fully automatic, fully process monitored, and intelligent workshop in the industry. The direct labor is reduced by 36% as compared to peers, and the labor efficiency reaches 7.1 megawatt per person per year, which is again the highest in the industry. At the same time, we are the first company to introduce an automatic material handling system and an automatically timing dispatch system.